this video session we will number one static CMOS circuit design, dynamic CMOS circuit design, and number 3 Euler's rule for physical design. So we will start from static CMOS circuit design. So let's have a problem, that is y is equals to AB plus C D plus E whole bar. For designing the static CMOS circuit design, here is the equation for which we are going to apply the static CMOS design. Okay, so we will start. सबसे पहले हमें एक चीज ध्यान में रखनी होती है, दैट इज जो रूल होता है PMOS और NMOS के लिए, फॉर PMOS एंड NMOS. PMOS के केस में जब भी मल्टीप्लाई होगा और प्लस एंड multiply and this is plus. So for NMOS plus के केस में हम लोग पैरेलल लेंगे and multiply के केस में we will go with series. PMOS के लिए ये चीज उल्टी हो जाती है, that is opposite, and it will be dot for parallel and plus for series. Okay, this thing, the you can memorize it like for NMOS, P for plus same as P for parallel, and dot for series, and PMOS will be opposite to the NMOS. Okay, so here it is, like for static CMOS circuit design, A and B are in parallel, sorry, in multiplication. So we will design like the two things, VDD, and the second line is, that is ground. सबसे पहले ये दो लाइंस ड्रॉ करनी है, VDD and ground. So for we will first draw for NMOS. Our equation is AB plus CD plus E. So here it is AB, that is A into B. A into B means for NMOS it is in series. So we will take a MOS circuit is A, in multiplication we will go with series. So here it is B. Okay, so now AB for NMOS it is in series. Now addition, that is in parallel. So C and this whole section will be in parallel. So we will start from here. C, that is here it is C, and now it is again in multiplication, that is C and D plus E are in series. So C and D plus E are in series, but D plus E are getting added, so they will be in parallel. It will be like this and this. Here it is D and here it is E. Now connect all these like this and take it ground. So this section is for NMOS. Okay, now we will draw for PMOS. We will start it from here. Now for PMOS, A dot B are in parallel, so we will go like this. This is A and this is B, two PMOS. Now it is getting added with C. Added means again in parallel, so they are multiplying in parallel. Now adding, sorry, for addition it is in series. So in addition, again like this, and now C is in multiplication, and D plus E. So C will be in parallel for PMOS, like this C, and D plus E, that is D, and they are getting added, so will be taken in series. So it will be like D and it is E. Here it is D and here it is E, sorry, with bubble because it is PMOS. Now we will connect it like this and this. Now this circuit is for PMOS. Now it is the point from where we will take the output Y. Here we have the whole static CMOS circuit for this given equation. Now we will discuss dynamic. For dynamic section, we will assume the PMOS as X. This whole circuit is taken as X, and the NMOS, the whole circuit is taken as Z. So for dynamic, we will go with dynamic CMOS circuit design. So what is the difference? First of all, what is the difference between static and dynamic? In static, we do not have a clock, but in dynamic we have a clock signal. So we have to do nothing, just like the same. The problem was y is equals to ab plus c into d plus e and whole bar. So here it is vdd, and again at this point we will go with ground. Now the same, we are working with dynamic, so we will have to take clock signals also. So for PMOS we will take a PMOS here, and for NMOS we will take N signal here, and this both are short, and a clock signal is given, that is phi clock signal. Okay, now that whole section, that is for like in static, we drawn here. This section for PMOS we taken as X. So हम लोगों ने यहाँ पे ये circuit हो गया X, and here it is Z, and this is for Y output. एग्जाम्स में आप ये पूरा सर्किट ड्रॉ करना, वरना मार्क्स ऐसे शॉर्टकट में मिलेंगे. So finally we have the dynamic. This whole section is dynamic static CMOS circuit for this particular problem. Now we will go with third section, that is Euler's rule for physical circuit design. Physical design. Now for Euler's rule, we will work with static CMOS circuit. Now Euler's के लिए हम क्या करते हैं? This is the VDD things. We will start with this section, this point. Okay, ये point, this point. As you can see, we will draw a point, that is VDD. हम लोग क्या करेंगे? हर नोड पे, जैसे this is node 1, this is node 2, this is node 3, this node is 3, this is 4, this is 5, and this node is 6. Okay, now ये हमारा VDD at node 1. A के लिए हम लोग एक पाथ बनाएंगे, that is this is A. For B it is like B. Now for C we will go like this, because C is going through this. Now D and E. So this is D, and for E it is D and it is E. this is the node A, this is node, sorry, 1, 2, it is 3, and let it is 4, this node as 4, so here it is 4. Okay, now this is for NMOS, sorry, PMOS. We will draw another one for NMOS, that is, this is the node 3, as it is going through like this. A, it is A, it is B, B is like this. Now here it is C, so C, it is like this, C and D and E. So E, here it is D and here it is E, it is D, it is E, connected like this, and this one is ground. So जब हम लोग ये diagrams बना लेंगे, now we will go with Euler's path. ठीक है, Euler's path, हमें शॉर्टेस्ट डिस्टेंस चाहिए इस सेक्शन से, मीन्स हम लोग जैसे यहाँ से स्टार्ट करना है तो दिस पाथ, दिस एंड दिस, सारा एक पाथ हुआ। हमें पाथ इस हिसाब से डिसाइड करना है कि इस पाथ, इसका और इसका पाथ सेम रहे। लाइक हम लोगों ने इस पॉइंट से स्टार्ट किया, हम लोग इस पे जा सकते हैं ऐसे, फ्रॉम ए बी डी ई एंड सी, एंड रिमेंबर एक बात 2 बार रिपीट नहीं होनी चाहिए। ओके, सो जैसे हम लोगों ने इसमें स्टार्ट किया फ्रॉम ए, दैट इज हम लोग गए ए से बी, बी से डी, डी से ई एंड देन ई से सी। अब सेम यही पाथ हमें इस वाले दैट इज एनमॉस पे ट्राई करना है कि ये पाथ इस पे भी चल रहा है कि नहीं। सो हम लोगों ने किया था फ्रॉम ए टू बी, B to D, D to E and E to C. So as you can see, जब हम लोग D से E पे जा रहे हैं, सॉरी D से E पे जा रहे हैं और उसके बाद हमें C पे जाना है, दैट इज E से C, तो हमें इस वाले को रिपीट करना पड़ रहा है। सो हम लोग इस वाले पाथ को नहीं लेंगे। अब हम लोग चलेंगे, हम लोगों ने ऐसे चलना है, जैसे हम लोग यहाँ से स्टार्ट करेंगे D, सॉरी D, यहाँ से स्टार्ट करेंगे D, फिर जाएंगे हम लोग B पे, B से A से C एंड C से फिर A, सॉरी C, A के बाद C एंड C से फिर E। नाउ अब हम लोग ये बात इस पे अप्लाई करेंगे, इट इज लाइक ये सही चलता है कि नहीं। सो इट इज, वेयर इज D, D, दिस पॉइंट, D, B, A, C एंड हियर इट इज E। सो यू कैन सी जब हम लोग ये वाला पाथ इस पे अप्लाई कर रहे हैं तो कोई भी पाथ रिपीट नहीं हो रहा है। सो दिस इज द राइट Euler's path. Okay, now अब हमें इन पाथ्स के लिए सर्किट बनाना है, static circuit. So the problem was y is equals to AB plus C into D plus E. Okay, so and the path we decided is D, B, A, C and E. Now the same thing as we drawn as static and dynamic, that is VDD, and here it is ground. Now we are drawing the stick diagram, that is the same one. So here it is for PMOS and it is for NMOS. Okay, now this is the path, so we will go like this. It is D, B, A, C and E. Now we have to draw the stick diagram for this section. Okay, now let's again take the static circuit. So as you can see, here it is, source of the PMOS A, drain, source, drain, source, drain. It is again source, drain, source, drain. Now for NMOS, it is drain, drain, source, drain, source, source, drain, drain, source, and source. Okay, so for we are drawing for a PMOS, that is this section. So we will see the transistor D. So for transistor D, we have S and D. So we have to see D and B transistor, that is these transistor D and B. As you can see, the D and S are on same junction, so we will take the drain. As you can see, drain of the B, that is drain of the B, is connected with the source of the D. So here it is. Now it is the drain and it is the source. This is A and B. A and B, the sources of the A and B are on same side, so it is source and it is drain. Now A and C, as you can say, A and C, drain of A and source of C, sorry, so drain of A, source of C. Okay, now C and E, C, drain of C and source of D, sorry, drain of E. So drain of C and drain of E are in non-same, so it is source. Here it is. Now we will do the short circuits for these junctions. This, this. As you can see, here it is. The A and B are short. A and B, sorry, for source. This point is connected with VDD. As you can see, the source of A and source of B are given with VDD. So source of A and source of B are given with VDD. Now A and B, the drain of A and drain of B are short. So drain of A and drain of B and drain of A are short. Now again you can see the source of D, the source of D and source of C, source of D, source of C, source of D and source of C are also short circuit. So this junction is completed here. After that we will move to this junction D and E. We will see D and E. Here it is D, it is E. So the drain of D, that is this point, drain of D and source of E, that is source of E. These are again will short it. Now again this point C and E, C and E, drain, these are already shorted. Okay, now we will take the output. This is from this point, drain of C and drain of E, that is drain of C, drain of E. This section we will do it like this, and here it is Y. Now we will draw for work for the NMOS. Sorry, for NMOS we are seeing this circuit. Now similarly, this is the drain, this is the drain of A and C. We will go with A and C. The drain of A and C are common, so the drain of A and C. Okay, so here it is source, here it is source. Now we will move with this drain of source of A. We'll go with this side, so D and E, D and E. Now so we will work with DB. These two are together, so D, the source of D is connected with source of E. B and D, B and D, sorry, yes, source of B is connected with source of B. So source of D is connected with source of B. So here it is drain. Now C and E. The source of C is connected with drain of E. Source of C is connected with drain of E. So here it is D and here it is S. Now again the short circuits. First of all we will take the output, that is A, drain of A, and drain of C. Drain of A and drain of C, here it is taken as, the output is taken from this point. Okay, now again from ground to ground, that is D and E. The sources of D and E, D source of D, source of B, D and E, source of D, B to ground, and source of this, here it is also ground. Okay, now this point B and A and B are short. Okay, C and D, C and T, these are apart, so these are also have to be shorted. So the drain of C, that is drain of C, this section, and drain of A, that is drain of, here it is drain of A, these are also short. Okay, sorry, C, A, C are together, C and D are far, C and D. So source of C and drain of D, here it is. So you can see it is also connected, D is connected with E, the drain of C, D, and this is also shorted. Yeah, okay, done. So it is the stick diagram. So now the question is, हमें यूलर्स रूल की ज़रूरत कब पड़ेगी? सो आप देख सकते हो कि ये हमारे पास एक कॉम्प्लिकेटेड इक्वेशन है विद A, B, C, D, E with 5 transistors. Okay, so for drawing stick diagram for this equation हम डायरेक्ट नहीं बना सकते हैं. क्योंकि हम लोग डायरेक्ट इक्वेशंस बना सकते हैं, जैसे y इज इक्वल्स टू a डॉट b, इसके लिए हम लोग स्टिक डायग्राम डायरेक्ट बना सकते हैं. दैट इज अगर हमें सिर्फ 2 वेरिएबल के लिए स्टिक डायग्राम बनानी है तो हम नॉर्मली बना सकते हैं. बट अगर ट्रांजिस्टर्स ज़्यादा हो जाते हैं, दैट इज़ वेरिएबल्स ज़्यादा हो जाते हैं, तो स्टिक डायग्राम के लिए यूलर्स रूल का यूज़ होता है. यूलर्स रूल फॉर physical design. So that's all for today. Thank you very much.